the world you know is gone. 66 million years ago, an asteroid 6 miles wide struck the Earth with the force of 10 billion atomic bombs. The impact triggered a global firestorm, tsunamis that washed halfway across continents, and threw so much dust and vaporized rock into the atmosphere that it blocked out the sun. For months, perhaps years, the planet was plunged into a dark, freezing winter. Photosynthesis ground to a halt. The food chains collapsed from the bottom up. The reign of the dinosaurs, a dynasty that had lasted for over 150 million years, ended not with a whimper, but with a cataclysmic, deafening roar and then silence. But the question isn't just about the end, it's about the beginning that followed. Could Earth sustain the era that rose from these ashes? That era was the Paleocene, the first chapter in the age of mammals. And the answer is yes. But the world it sustained was a fever dream. A ghost world unlike anything that came before or after. It was a planet hitting the reset button. Imagine standing in the first 1,000 years after the impact. The air is thick with a chemical haze. The ground is a blanket of ash and iridium-rich clay, the tombstone of the Cretaceous. Acid rain, a consequence of vaporized sulfur-rich rock, has poisoned the lakes and oceans, dissolving the shells of countless marine organisms. The great forests are gone, replaced by skeletal, burnt-out husks. Life itself has been filtered through a brutal sieve. Anything larger than a raccoon was, with very few exceptions, annihilated. The first life to reclaim this wasteland wasn't grand or majestic, it was the ultimate opportunist, the fern. For centuries after the impact, the planet was smothered in a near monoculture of ferns, an event so distinct in the fossil record, it's called the fern spike. They were the emergency first responders of the botanical world, capable of growing from spores carried on the wind, thriving in the disturbed, nutrient-poor soil. This was a monotonous green and grey world, a far cry from the vibrant ecosystems of the dinosaurs. But beneath the fern fronds, the real story was unfolding. The survivors were small, secretive, and adaptable. They were the creatures that had lived in the shadows of the dinosaurs. Insects, amphibians, lizards, snakes, crocodiles, birds, and of course our own ancestors, the mammals. For millions of years, mammals had been little more than bit players, shrew-like or badger-sized creatures scurrying through the undergrowth at night, terrified of being stepped on. The asteroid didn't just kill the dinosaurs, it evicted them. And for the first time in Earth's history, the grand global real estate of every ecological niche was suddenly vacant. The Paleocene climate was the engine of this new world. After the initial impact winter, the planet began to heat up and it did not stop. Massive long-term volcanic activity, particularly from the Deccan Traps in what is now India, had been pumping colossal amounts of carbon dioxide into the atmosphere even before the asteroid hit. With the sun-blocking dust settled, this CO2 created a powerful greenhouse effect. The Paleocene became a hothouse world. There were no polar ice caps. The temperature difference between the equator and the poles was perhaps half what it is today. Palm trees grew in Greenland. Subtropical forests, dense and humid, flourished in places like Wyoming and Montana. The entire planet was wrapped in a blanket of warm, moist air. It was a global sauna, and it was in this sweltering, soupy environment that life began to experiment. The ferns eventually gave way. The angiosperms, the flowering plants, which had been a recent evolutionary innovation in the late Cretaceous, now exploded across the globe. They diversified with incredible speed, evolving new ways to use insects and animals to pollinate and spread their seeds. Legumes, the family of plants that includes beans and peas, appeared, and their ability to fix nitrogen in the soil was a game changer, refertilizing a wounded planet. The world became a jungle. Not the open woodlands or plains we might imagine, but dense, multi-layered, swampy forests stretching from pole to pole. This was the new buffet, and the mammals, our tiny, trembling ancestors, were ready to eat. The first few million years of the Paleocene saw an evolutionary explosion known as an adaptive radiation. It was nature's R&D phase for mammals. Think of it as a chaotic sketchpad, with evolution trying out dozens of new designs, many of which were bizarre and ultimately doomed. These weren't the familiar mammals of today. Most belong to archaic groups that have no living descendants. Take the multituberculates like Tilodus. They looked like squirrels or rodents with grasping feet and long tails, but they belonged to a completely separate, ancient lineage of mammals that had coexisted with the dinosaurs. They were one of the few mammal groups to do well both before and after the extinction, but they would eventually be outcompeted by true rodents and vanish. Then there were the pantodonts, the first group of mammals to achieve large body size. A creature like Barylambda was a vision of early mammalian awkwardness. It was the size of a bear, with a ridiculously small head and brain, five-toed pillar-like legs, and a massive, heavy tail it may have used as a tripod to help it rear up and pull down branches. It was a herbivore, a walking evolutionary experiment that looked like a cross between a hippo, a bear, and a giant ground sloth. It was successful for a time, a placeholder for the great herbivores to come, but its design was clunky, inefficient. On the carnivore side, there were the mesonychids. Imagine a wolf, but instead of paws with claws, it has hooves on its feet. These were some of the top predators of the Paleocene, like Ankylodon. They were wolf-like in their role, but their biology was completely different, belonging to an early group of hoofed mammals that somehow took a turn towards predation. They were the first attempt by mammals to fill the large land predator niche left vacant by the tyrannosaurs and their kin. They were so strange, so unlike anything alive today, that they perfectly encapsulate the weirdness of the Paleocene. This was a world populated by first drafts, by creatures cobbled together by evolution in a hurry to fill the void. This hothouse world with its endless lush vegetation could easily sustain these early inefficient models of mammalian life. There was so much food and so little competition that even a clumsy, small-brained design like Barylambda could thrive. In the skies and on the ground, the dinosaurs weren't entirely gone. One lineage survived, the birds, and in the Paleocene, some birds took the opportunity to reclaim the terrestrial throne of their theropod ancestors. These were the first of the terror birds. In Europe and North America, a creature like Gastornis was a terrifying sight. It stood over 6 feet tall, was powerfully built, and sported a massive hatchet-like beak capable of crushing bone. For millions of years, in many parts of the world, a giant flightless bird was the apex predator. The mammals were still relatively small and clunky. It was the birds that truly ruled the forests. Down in the swamps and rivers, the other great survivors of the extinction, the crocodilians, flourished in the global heat. They grew to enormous sizes and diversified, spreading all over the world. They were a constant threat in the warm, sluggish waterways of the Paleocene. And alongside them lurked a true monster, a testament to just how hot the planet was. In the swamps of what is now Colombia, we find the fossils of Titanoboa cerrejonensis. This was a snake that reached lengths of over 40 feet and weighed more than a ton. A creature this large and cold-blooded could only have survived if the average ambient temperature was incredibly high, perhaps over 30 degrees Celsius or 90 degrees Fahrenheit. The existence of Titanoboa is one of our best physical proofs of the extreme greenhouse climate of the Paleocene. The world sustained it because the world itself was a giant incubator. The Paleocene was a sustainable world, but it was a system in recovery, and it was building towards a crisis. All that carbon in the atmosphere that kept the planet warm was a loaded gun, and at the very end of the epoch, about 56 million years ago, the trigger was pulled. This event is known as the Paleocene-Eocene Thermal Maximum, or PETM. Over a period of a few thousand years, a geological instant, an immense amount of carbon was released into the atmosphere and oceans. The exact cause is still debated. Leading theories include the sudden melting of frozen methane hydrates on the seafloor, or massive volcanic eruptions cooking organic-rich sediments. Whatever the cause, the effect was catastrophic. Global temperatures, which were already high, shot up by another 5 to 8 degrees Celsius. The poles became almost tropical. The oceans suffered immensely. The vast injection of carbon dioxide turned them acidic, a process called ocean acidification. For countless species of deep-sea shelled organisms, the water became corrosive. A mass extinction event swept through the deep oceans, wiping out 30-50% of benthic foraminifera, the tiny organisms that formed the base of many marine food webs. On land, the rapid warming caused a massive migration of plants and animals. Mammals, which had been diversifying throughout the Paleocene, were profoundly affected. The PETM event seems to have been the catalyst for the appearance of the first modern mammal orders. The first true primates, our distant ancestors, appeared. The first even-toed hoofed mammals, the ancestors of deer, cattle, and pigs, and the first odd-toed hoofed mammals, the ancestors of horses and rhinos, all show up in the fossil record right at this time. It's as if the extreme climate shock cleared the deck of the archaic Paleocene mammals and accelerated the evolution and spread of the more modern, adaptable groups that would go on to dominate the planet. So could Earth sustain the Paleocene? Yes, it did. It sustained a recovery from near total annihilation. It sustained a global humid jungle populated by strange experimental animals and giant birds. But the real lesson of the Paleocene, and especially the PETM, is a cautionary one. The Earth system can sustain a high CO2 hothouse world. Life will eventually adapt. But the transition, the change itself, is brutal. The PETM was one of the most rapid and profound climate change events in the last 66 million years, and it caused a global biological crisis. Today, we are releasing carbon into the atmosphere at a rate that is estimated to be 10 times faster than what triggered the PETM. We are recreating the conditions of that ancient fever spike, but we are doing it on a time scale so fast that the ability of ecosystems and species to adapt is severely limited. The Paleocene shows us that the Earth is resilient. It can absorb incredible punishment and life will in some form go on, but it also shows us that there is a profound cost to rapid environmental change. The world it sustained was alien and strange, a planet recovering from one catastrophe while slowly building towards another. It wasn't a failure to be the Cretaceous, nor was it an imperfect version of the world to come. It was itself, a 10 million year long exhalation after a global trauma, the murky, humid, and deeply weird dawn of our own age. Studying it is like looking at a ghost in the geological record, a ghost that warns us of what happens when you turn up the planet's thermostat too high, too fast. If you enjoyed this video, then subscribe for more, and feel free to leave your suggestions for what's next in the comment section down below.